In a profound shift in how we perceive the universe, recent physical insights suggest that gravity is far more than a simple pull, it is a fundamental braking system for time itself. From the subtle aging difference between a person's head and feet to the absolute stillness at the edge of a black hole, the fabric of reality behaves less like a rigid stage and more like a flexible membrane capable of slowing the march of existence to a complete halt. For centuries, the classical Newtonian view held that time and space were absolute and unchanging, a fixed backdrop where the drama of the universe played out. However, the modern understanding of general relativity reveals that mass actually warps this backdrop. Imagine a heavy bowling ball placed on a trampoline. It creates a depression that forces nearby objects to roll inward. This curvature is what we experience as gravity. Crucially, this warping affects not just space, but time. Clocks closer to a massive body, such as the Earth, run measurably slower than those further away. This is not a psychological trick but a physical reality verified by Global Positioning System satellites, which must artificially adjust their internal atomic clocks by 38 microseconds every day to remain synchronized with the slower time experienced on the ground. The intensity of this effect scales with density. While the Sun, with a mass 330,000 times that of Earth, causes only a slight drag on time, a black hole represents the ultimate extreme. If the Sun were compressed into a sphere only 6 kilometers wide, its density would become so immense, equivalent to squeezing the weight of every car on Earth into a single sugar cube, that it would tear a hole in the fabric of spacetime. At the boundary of such an object, known as the event horizon, the breaking of time reaches its limit. To an outside observer watching a traveler fall toward a black hole, the traveler would appear to slow down as they approach the horizon. Their movements would stretch from seconds into years, their image would redden and fade, and they would ultimately appear frozen in time forever at the edge, never truly crossing over. From the perspective of the traveler, however, time proceeds normally as they drift into the abyss, highlighting a terrifying disconnect in the shared reality of the universe. Further complicating this cosmic mystery is the holographic principle. Recent theories suggest that black holes may act as the universe's ultimate hard drives. Rather than information being lost inside the volume of the black hole, it appears to be encoded on the two-dimensional surface area of the event horizon. This discovery implies a startling possibility for the rest of reality, that our three-dimensional world, and everything within it, might simply be a projection of information stored on a distant, flat boundary. If true, the universe is not just a collection of objects, but a vast holographic image where time, space, and information are inextricably linked by the gravity of these dark, celestial anchors.